Hello and a very good day. Today I would like to present about memory management for operating system. What is memory management? Memory management is the task carried out by the operating system and hardware to accommodate multiple processes in main memory. If only a few processes can be kept in main memory, then much of the time all processes will be waiting for input-output and the CPU will be idle. Hence, memory needs to be allocated efficiently in order to pack as many processes into memory as possible. There are two main memory partitioning techniques, which is fixed partitioning and dynamic partitioning. A program may be too big to fit in a partition, so the program needs to be designed with the use of overlays. Main memory utilization is inefficient. In any program, regardless of size, memory occupies an entire partition. In fixed partitioning, main memory is divided into a number of static partitions at system generation time. A process may be loaded into a partition of equal or greater size. While in dynamic partitioning, partitions are created dynamically so that each process is loaded into a partition of exactly the same size as the process. There are few strengths and weaknesses in fixed and dynamic partitioning. In fixed partitioning, it is more simple to implement than dynamic partitioning because little operating system has overhead. In dynamic partitioning, there is no internal fragmentation that will happen. It is a more efficient use of main memory compared to fixed partitioning. The weakness of fixed partitioning is it has inefficient use of memory due to internal fragmentation. There are maximum number of active processes is fixed in fixed partitioning. So, why do we need dynamic partitioning? It enables partitions of variable length and number. Also, process is allocated exactly as much memory as it requires. To overcome some of the difficulties with fixed partitioning, an approach known as dynamic partitioning was developed. With dynamic partitioning, the partitions are of variable length and number. When a process is brought into main memory, it is allocated exactly as much memory as it requires and no more. There are three placement algorithms in dynamic partitioning. The first one is best fit, second is first fit, and the next is next fit. Best fit is choosing the block that is closest in size to the request. First fit is begins to scan memory from the beginning and chooses the first available block that is large enough. Next fit algorithm begins to scan memory from the location of the last placement and chooses the next available block that is large enough. Figure 7.5 shows an example of memory configuration after a number of placements and swapping out operation. The last block that was used was a 22 megabyte block from which a 14 megabyte partition was created. The figure shows the difference between the best, first, and next fit placement algorithms in satisfying a 60 megabyte allocation request. Best fit will search the entire list of available blocks and make use of the 80 megabyte block, leaving a 2 megabyte fragment. First fit results in a 6 megabyte fragment, and next fit results in a 20 megabyte fragment. Best fit will search the entire list of available blocks and make use of the 80 megabyte block, giving a 2 megabyte fragment. The first fit algorithm is not only the simplest, but usually the best and fastest as well. The next fit algorithm tends to produce slightly worse result than the first fit. The next fit algorithm will more frequently lead to an allocation from a free block at the end of memory. The result is that the largest block of free memory, which usually appears at the end of the memory space, is quickly broken up into small fragments. On the other hand, the first fit algorithm may litter the front end with small free partitions that need to be searched over on each subsequent first fit pass. The best fit algorithm, despite its name, is usually the worst performer because this algorithm looks for the smallest block that will satisfy the requirement. It guarantees that the fragment left behind is as small as possible. What is buddy system? A buddy system is comprised of fixed and dynamic partitioning schemes. Space available for allocation is treated as a single block. Memory blocks are available of size 2K words, in which K is lower than L and lower than U, where 2L, smallest size block that is allocated, 2U is largest size block that is allocated. Generally, is the size of the entire memory available for allocation. Figure 7.6 gives an example using a 1 MB initial block. The first request, A, is for 100 kilobytes, for which a 128K block is needed. The initial block is divided into 512K buddies. The first of these divided into 256K buddies, and the first of these is divided into 128K buddies, one of which is allocated to A. A is the first request. The next request, B, requires a 256K block. Such a block is already available and is allocated. The process continues with splitting and coalescing occurring as needed. Note that when E is released, two 128K buddies are collapsed into 256K block, which is immediately collapsed with its buddy. Buddy system means that from initial memory, it is divided into two blocks of equal size, according to the request and allocation. Figure 7.7 shows a binary tree representation of the buddy allocation immediately after the release of B request. The leaf nodes represent the current partitioning of the memory. If two buddies are leaf nodes, then at least one must be allocated. Otherwise, they would be collapsed into a larger blocks. The buddy system is reasonable to overcome the disadvantages of both the fixed and variable partitioning schemes. But in contemporary operating systems, virtual memory based on paging and segmentation is a better practice. To summarize this presentation, there are three partitioning techniques, which is fixed partitioning, dynamic partitioning, and buddy system. Buddy system is a part of dynamic partitioning. Strength of fixed partitioning. It is simple to implement with less overhead. Weakness. It is inefficient and can cause internal fragmentation, while for dynamic partitioning, its strength includes no internal fragmentation, it is efficient use of main memory, while its weaknesses is it is inefficient use for processor. It needs compaction. Buddy system has its strengths such as less overhead, more efficient use of memory. The weakness of buddy system is as it causes internal fragmentation. In my opinion, dynamic partitioning is the best use of memory as what matters is the efficient use of memory without too much waste. Thank you.